I start with the unimportant stuff, just a few quick words about who we are. Maybe you've seen our logo around. We have a new founded company called FHIR, which is the Greek word for bridge. So bridging is pretty much what we are focusing on. So we've started being involved with the FHIR community since 2014. So it's actually our fourth DevDays this year. And I started up doing version 2 mappings very early on FHIR, and I met a lot of issues. And I just want to tell you about some of the experience that I made and also how we solved these problems. So that you can reproduce what we did in these more than 7 connectathons now that we have participated with mappings from version 2 to FHIR. So the scenario I would like you to think about in your head, which is pretty much what this talk is going to be based on, is we have the issue, we have our version 2 based EHR, which is, you know, the 99% of EHR that are still out there. And usually we have integration engines working in these hospitals that receive the ADT or generally every version 2 message floating around in these hospitals and these organizations, and they distribute them to the different systems. So now suddenly we want to buy these fancy new mobile apps or the mobile devices that are all FHIR enabled, and maybe they even come with their own FHIR server, or we just pick one. I mean, there's plenty of FHIR servers freely available around. That's just a generic reference implementations that you can download and deploy in an instance. So no problem getting a FHIR server from somewhere. So you can hook up your fancy new equipment to the FHIR server, but the big question is, how do you get the patient demographics that these mobile apps need? How do you get them from your integration engine to that FHIR server, so that the systems, the FHIR-enabled systems, can access this information? Another very similar scenario might be this, that you are having all sorts of version 2 exporting systems around that are really have closed databases. You have no way of accessing the data that's in these systems. So the only way to make the data available is to catch everything that they export, every version 2 message, just everything that goes through the integration engine, maybe even from sources that have completely proprietary data, but maybe they too export whatever. So you might think that it's a good idea to take everything that you get from these systems that you have no other way of touching, and use your integration engine to normalize that, make FHIR resources of all these diverse data, and just store it in one generic FHIR server so that you have all your data available for queries. Because if it's in the FHIR server, you can access it all the time. You can do analysis, you can query it, but if it's still sitting in the V2 system, you always have to sit in front of it and wait for an event to happen and the message to fall out. You can't really actively query. So let's look at a very precise use case. Say we want to have an ADT A01 message, which is the event that announces that a new patient has been admitted to a hospital, and we want to make map this message into something that the FHIR server can understand. So, looking at this wonderful version 2 message, some of you may have seen this before. I think it's kind of funny. It really looks like it's from the 80s, right? I'm always waiting for Heckmann to come from the slide. Yeah, anyway. Okay, that's the message that we want to transform. And you know, us being FHIR people, we look at it and say, yeah, that's easy mapping that into FHIR. I mean, it's pretty obvious. We have this message header information, we have patient demographics, that's probably going to be a patient resource, We have information about the encounter, like when did the patient arrive and where was the patient, that goes into the encounter resource. And we have a couple of allergy intolerance information at the bottom, so that's probably going to be a number of allergy intolerance resources. So that's a pretty easy decision to make. So obviously, the result that we want to map to is a bundle of resources. But the next decision we have to make is what kind of bundle is it going to be, because there are plenty of bundle types around in FHIR. Looking at the specification, you can see right here at the top you have the bundle type, and this could be either a document, a message, transaction, batch, history, search set, and collection. So it's got to be any one of those. And I mean, the obvious answer is it's going to be a message, because it's a message coming in, so it's probably going to be a message going out. But when you look at the specification for the messaging in FHIR, you will find that your message needs to have an event, like the version 2 message has an event saying it's ABT A01, this is your patient admission. In FHIR, you would expect to find a similar event definition and a message definition associated with the event that tells you what structure the message with this kind of event is supposed to have. So which resources go in there and what cardinality, what order, what other reference resources need to be included, and all that kind of stuff. That's what we have this message definition framework for, to define these events and the associated messages. However, at this point in time, we don't have any definitions of what these events could be and what the associated messages look like. And in consequence, if we were to map this V2 message to a FHIR message, we would have to define the event, we would have to define the associated message structure, and we would have to define what business logic we expect the receiving system to run through when it's processing the message. However, if you remember the scenario I gave you up front, was we're just using any random reference implementation server that has a full-fledged FHIR API front end, but no business logic whatsoever in the back. It's just basically a bucket that you're throwing resources in. So in order for this system to be able to process a FHIR message, and assuming that we already had the message defined, it would have to have an implementation of business logic for this exact event in order to process the message correctly. So if we were to use messaging in combination with version 2 mapping, we would have to define maybe not all version 2 events, maybe we could reduce them to a number of really important events, or maybe we'd find a lot of events that would behave in the same way on the back end. But we pretty much would have to re-implement version 2 with FHIR. We'd have to define the events, we'd have to define the message structures and the associated business logic. So finding a FHIR server that supports all that, all these different kinds of business logic, is probably going to be a bit hard. So what do we do with our real stupid but full-featured FHIR reference server? How do we get the data into that? The advantage is that we have an integration engine in the middle, and we, the people doing the mapping, know what the events mean. So we can kind of emulate the business logic on the integration engine, because we can tell the server how to process this event, or what action the server needs to take to process this event. And the vessel that allows us to give both the resources and the instructions of what to do with them to the FHIR server is the transaction type bundle. Because if we use transaction type bundles, we can use this request part at the bottom for each entry in the bundle, and that's exactly where we are going to detail to the server what we expect the server to do. We can give an HTTP verb saying whether we want to add a resource or update a resource. We can give a URL endpoint at which we want this HTTP action to happen. We can add header data for this HTTP interaction, and we can add the actual resource that we want to send to the system. So going back to our ADT A01 event, let's look at it again and decide what we want the server to do with these individual resources. When it's, since ADT A01 means we have a new patient arriving, a new encounter that's being started, we do not know whether that patient has been here before. It might be his second encounter, he may have been already in the system, so we can't really say for sure whether we want to create that patient, or maybe we just want to update a patient that's already in the system. The message doesn't tell us whether the patient already exists in that case. For the encounter, that's definitely going to be a create, because that's what the event says. We have a new encounter. And for the allergy intolerances, that usually the semantics of these version 2 messages is usually a purge and create. So whenever we receive an ADT message that has allergy intolerances, we would expect the receiving system to purge all previously known allergy intolerances and accept the new ones. We can't just always add allergy intolerances, because then we would end up with a huge list with many replications and double entries. So that's basically what we would want the receiving system to do. So now we have to explain that in terms that the server understands, and the terms are REST. So we have to restify our instructions. First question is, how do we do that updates/create we don't know which thing, where we actually need to check whether the patient already exists on the server, and if it does, we will want to do a put, so an update on that particular patient. If it doesn't exist, we want to do post. So what this would be, in plain REST, would be multiple interactions between client and server, but we want to do everything in just one transaction bundle because we are lazy. So this is where the conditional update comes in very handy, because the spec says you can use conditional update if you don't know whether the resource already exists, or if it exists, you don't know its ID or its URL. So instead of putting the actual location of the resource into the URL, we just put in the criteria by which we would determine whether we already know that patient or not. And in a V2 environment, that criteria would always be the patient identifier. That's exactly what we would do if we were to do it manually. We would search the patient by identifier, and if we find one, so if we have one match, we would perform the update. If there was no match, we would do a create instead. And if there are multiple matches, we have to error, because we don't know what to do. I mean, we have multiple patients with the same identifier, how do we know which one we want to update? So that's going to be an error condition in our scenario. And that's exactly what this conditional update is doing for us. It's basically searching the patient by the parameter that we're giving in the URL, and then acts accordingly. So in order to get the criteria for the search right, and not by accident having too many results that would cause an error to occur, we have to make sure that our criteria identifies the patient uniquely. So identifier is definitely going to be our criteria. So when we look at the V2 message, we have in this example we have multiple identifiers. For those who are not familiar with V2, this I don't know what is this called in English? I don't know. Tilde? Okay, that's the repeating sign. So we have two identifiers. This is the first one. This is the second one, and we have different namespaces. In this case, in the V2 message, we just have like a short code for the namespace. In this case, it's the NHS, meaning it's a UK national patient identifier, and the other is a medical record number, which is maybe the internal identifier for this particular hospital. So if we want to map these two identifiers to be proper FHIR identifiers, we have to assign proper namespaces. So in In FHIR, we would use probably the OID for the NHS number, which would be expressed as a URN. Or we would have a URL as namespace identifier for that particular hospital. So that would basically be how we determine whether the patient already exists, by looking if there's a patient on that system that has this identifier from this particular namespace. So the next problem that we have, by the way, it's going to be the same for the encounter, basically. You know, I said with the encounter, it's always going to be a create, but then again, we have to think that just by accident, we might accidentally resend the same message, or so we never know for sure whether the encounter isn't maybe already here. So just to be safe, I would just use the same procedure with the encounter and do a conditional update to check whether the encounter with this particular identifier already exists, and if so, we just do an update just to make sure. So, but a different problem we have to solve is with this purge/create that we would use, that we would need for the allergy intolerance resources. So, what this means is we have to delete all the allergy intolerances we already have on the system, so we don't have duplicates. And then we have to post the new ones. However, we have to be very careful right here, because someone else may also have added allergy intolerances for that patient. And the semantics of the V2 message is only delete those that have been previously transmitted by this version 2 message, and not delete all allergy intolerances for that patient. So we have to make sure we only delete the ones that also came from our V2 data stream, not from different sources. So again, the conditional delete is going to help us out on this one. So we can put a delete interaction into our transaction, and instead of telling explicitly which resources we want to delete, we can add a condition. So we need to be able to recognize the allergy intolerances that we previously submitted. So there's basically two ways of achieving that. The proper way to do it, to trace what resources came from which source, would be to enter a provenance resource. So whenever we create a transaction bundle, we add a provenance resource in that references all the other resources, and in the provenance resource itself, it's stated where this information came from, maybe what the name of the integration engine is, what the name of the original source system was what the original ID of the incoming message was, and we may even place the original version 2 message into the body of the provenance resource, so we can really trace back where our information came from. And in this case, that would help us also later on to detect which of these allergy intolerances on the server came from our V2 data stream. An easier way to achieve the same thing, but it's more simple but not as powerful as using provenance, would just simply to tag all the resources that we are putting on the server. We just slap on a little tag that says this resource has been created by that system, and whenever we want to delete these allergy intolerances, we just check for the ones that we tagged with our label. So that's what the conditional delete would look like. We would say in the transaction, our verb, HTTP verb, would be the delete, and the URL that we want to target this interaction to would be the allergy intolerance with the criteria, which is both the patient identifier, because we want to delete everything that's connected to that patient, but only the ones that have our tag on. So that would be the way we would do it if we had tagged our resources. So if we were to create a provenance resource like this, it would be a little more complicated to determine which resources to delete If you look at the provenance resource, we have a target reference that would be the pointer going to all the allergy intolerances that have been created by the system. And the agent, that would be the criteria that tells us that we created these resources. Yes?
I wonder, there is a FHIR element in allergy intolerance. You can also use a system.
The identifier system, yes. That's actually one thing that I started up doing. That was my initial idea, to say I give these allergy intolerances identifiers, give them my naming system URL, that's how I recognize them, right? But then again, your search criteria would be, give me all allergy intolerances where identifier equals naming system type nothing, because you don't know the actual identifier. That's something that's supported now in the spec, but only after I entered the change request. So when I started up doing it, it wasn't possible yet. So, but you're right, it's supported now, yes. Okay, so let's assume that we have these provenance resources pointing at all of our allergy intolerances through its target property, and having that our unique name identifier or whatever in the agent element. So in order to rediscover our resources, we have to use something that's also been just recently introduced in STU3 after the change request, which is the reverse chaining, because now we have to ask the server to give me all allergy intolerances of that patient that have a provenance resource pointing at them where the agent is our device. And this kind of reverse chaining has not been possible before, so it has been added with STU3. So in our case, the criteria would be that we want to delete allergy intolerances with the patient identifier equals our identifier, and underscore has provenant, and the provenance agent is what we are looking for. Maybe it's a reference to a device, and the device has a name that we recognize as being us. That would be the criteria that we would use to select these allergy intolerances. So, now you may ask yourself, okay, that sounds fancy, but does that really work? I mean, that's quite a complex transaction that you got there, with all these criteria and conditionals and deletes and whatnot. We did it at a connectathon, and at first it didn't work, because the problem was that the transaction sequence in the spec was defined as first process all the posts, then process all puts, then process all deletes, and in the end do the gets. So that's the sequence that the server would go through the transaction. So it would first add our new allergy intolerances, then it would do all our conditional updates, and then in the end it would delete everything, or at least all the allergy intolerances, the one that have been there before, plus the one that we just added. So we'd always end up with no allergy intolerance whatsoever on the server. So again, change request, and now in STU3 we have this sequence which says first we do the deletes, then we process the posts, create the new resources, then we update everything, and if there's a get in that transaction, we do it at the very end. So now it actually works the way we would want it, we would expect it to. So that's pretty much the frame, or the vessel that you could use to explain the version 2 semantics to that server. Now comes the details, which is the field mapping, the field by field mapping of what goes where from the version 2 message to the FHIR server, to the FHIR resource. So Graham, in the previous session, Graham already gave you a few indications of how you could do that. Assuming that you have whatever integration engine is at your disposition, you would have to do it depending on how it works in there. But a good start is to look at the mapping tab on each resource, because that always gives you a hint of how these elements from the resource align with version 2 fields. So there's certainly not going to be one-size-fits-all V2 magic mapping that gives you the FHIR resource on the back end, because you know the saying goes, so you see one version 2 message, you see one version 2 message, because they never are the same. The structures are different by system, different by organization, so it's probably always going to be a lot of customizing on site when you do this kind of mapping. So, but what also can make your life a little bit easier if you can make your integration engine delegate all the terminology stuff to a FHIR technology server. So you don't have to do all the code mappings, all these, you know, you get one version 2 table of codes in, but you need to have another FHIR table on the output. So you could easily delegate that to a terminology server that has the concept map to do this, and you just call the translate option on the terminology server. Okay, so the last problem we have to solve is that in a version 2 message we have multiple objects in there, or as in version 2 it was called the segment, and the fact that they are that they belong to each other is implicit by the fact that they are in the same message. We just assume that this encounter belongs to that patient, but it's not explicitly stated in that message. FHIR, however, expects us to say exactly that, to link the encounter to the patient. Just by putting them in the same bundle, the server would never assume that these two resources need to be referenced. So we have to explicitly reference these resources. But how do we do that when we, as a client, don't even know what URL the server is going to assign to this new patient? Or we don't even know if it's going to have one assigned, it might be already there. And if it's there, we don't know what URL it already has. So what we can do is we can just create UUIDs for all the entries in our bundle, and then use these UUIDs to reference the resources in that bundle. And the server is expected that when processing a transaction bundle, or any kind of bundle for that matter, it has to replace the UUIDs with the actual URL it assigns to the resources. So for us, that means we just create a random UUID, put it in the entry.full URL, and then later down, when we want to reference that entry of the bundle, we just use the UUID as the target for that reference. So that may work well for ADT messages, because you pretty much just you're testing the patient with the conditional update. Yeah, you see if it's already there, and if it's there, you just update it, and then you can reference whatever else you have to that patient. However, if we think about ORU messages that we want to send back from a system to a primary patient administrative system, we may have the same kind of situation. We have a patient resource created from the PID segment in the ORU message, and we have a couple of observations that we want to reference to that patient. So, but in many cases, these systems that are sending the ORU messages are not the source of truth for patient demographics. We basically just have the PID message at all, or any patient demographics in that message, in order to know what patient these observations belong to. But we would never want to update the patient in the receiving system based on what we have in that ORU message. So if we do it like this, that would be dangerous. We would be basically wiping patient demographic data because the subsystem may know even less details than the original system has, and we may not even have the permission to do so. So in that case, we would rather use a conditional create, because a conditional create is defined as if the resource already exists, we just leave it alone. If it doesn't exist, we create a new one based on the information that we have, and then we just reference the stuff. However, if you don't have the permission to do any creates or updates on patient on that system, your transaction would fail no matter what you do, even if the patient already exists. You're not allowed to do any creates, so you'd always run into an error. So there's one way to solve that problem. We can use a conditional reference. It's a new feature that has been entered after I did a change request. So what we can do is, within a transaction, to say, we want our observation from that ORU message to reference a patient of which we don't know the full URL, but we know that it has a specific business identifier. And then again, the receiving server would be expected to resolve this search criteria to a unique match and replace it with the actual URL of that patient. Again, if there are multiple matches or no match, we would have an error. But then again, that's exactly the behavior that we expect when sending ORU message to a primary system. If it doesn't know the patient, it's supposed to error. If there are multiple patients with that identifier, then something really bad went wrong. If you have two patients with the exact same business identifier in the primary system. So in any case, we would get an error, which would be exactly what we want to have in this case. So there are a few limitations when you do this kind of hocus pocus on that integration engine. First of all, whenever you receive an update, oh sorry, there's a question?
How would you handle merges?
Merges, yeah, I'm coming to that.
Oh.
Coming, it's coming.
Sorry, last one. It's already available in DSTU3.
It's available, it's specified in STU3. I'm just not sure whether all the reference servers implement it. I've tested it with one server, but I don't remember which one it was. I think it was Happy. I wouldn't really want to vouch for the fact that all of the reference implementation is supported at this point. About the limitations. You have to remember that every time we process a new version 2 message coming in, we are, even if we do if this resource already exists and we do an update, we always replace the whole resource. So whenever one of these mobile apps floating out there and consuming these patient demographics adds anything to the patient resource or changes anything about the patient resource, every new V2 update would again, just replace all the data that already exists on that server and replace it. So sometimes that's going to be a problem if not all the V2 messages going out have the full data about the patient, and we might lose data when we update. So in some cases it might be safer to use a patch operation to just update one piece of information rather than replacing the whole resource. Then it may not always be the proper behavior on the server side to just in a RESTful way process these resources, because the server, depending on what its purpose is, may have to do additional stuff whenever a patient arrives. It may have to open an account or, I don't know, do any kind of stuff, so any sort of business logic. If that's required, if we have a requirement to invoke any kind of additional business logic, we would either need to define operation for that or use the messaging paradigm where we have specific business logic associated with the message event. Then, the merge is tricky, getting to that. And it doesn't work in the absence of RESTful protocol. So if you're talking to the system, to the receiving system, without the option of RESTful communication, you're better off with a message, because with the message, since it has the message header that has all the information of where this is coming from, where this is going to, and what happened and when and where and why, you can basically write that message on a jump drive and put it in an envelope and send it to a receiver who opens the envelope, plugs in this jump drive, and reads and processes the message. So there's more problems in the details, like for example in V2 nobody ever bothered to make a difference between an encounter and an episode of care. So when mapping PV1 segment, it probably depends on your use case whether it's the one or the other. So let's talk about merge. Usually servers aren't supposed to merge two patient resources. Instead of merging them, they are basically just linking these resources. Because each one of these patients may have an indefinite number of other resources referenced to them. So if we were basically to delete one of them, we would have to redirect all these references to the actual new patient. And that, in many cases, may not be feasible. And it's especially nothing you can do in the transaction bundle to tell that server to update all of its references. You can tell it to delete the one patient and maintain the other, but all the references then would, all the observations from the deleted patients would be lost. So rather than doing that, we rather link the patients together. So whenever I process a A40 message, I do the following thing. I have two patients, the one in the PID segment of that message, that's my good patient, that's the one that I want to keep. And in the merge segment, I have the bad ID, that's the old patient that I want to have gone, that's the duplicate. So I create a transaction bundle that has two identical patient resources in them. I create them from the information that I have in the PID. And one of them is going to have the good ID, and one of them has the bad ID from the merge segment. Then I create the conditional URLs accordingly so that we update both of these patients, the good and the bad. And we add links to these resources. The good patient gets a link to the bad patient that says this patient replaces the old one. And the bad patient gets a link that says this resource has been replaced by the other patient. So they are pretty much links going in both directions. So that whenever a client accesses the old patient, it can see that there's a newer patient. But if someone accesses the new patient, the good one, the client has the information that there's another resource that may have additional information about that patient with all the observations referencing it. So the last thing we have to do is we have to set the bad patient to inactive. We have to somehow label it as do not use this patient anymore. So the downside is that if we do this, since we're also updating the actual patient by adding this link, we are going to lose the information from the next of kin segment, because this information is not included in the A40 messages. And since we are updating the patient, we are replacing all previously known information. So unless there's another regular ADT message coming closely after our 40 message that will then again add the next of kin information, we're losing this information when you do it. So we might consider, if that's important to us, to maintain the next of kin information, to instead of updating the good patient, we might want to patch the link in. So, last problem is, what do you do if your server doesn't support transaction? I mean, that's pretty tough stuff we are requesting from the server API. So, but since we have basically all the logic explained in the transaction, you can easily write a generic script that just picks the transaction apart and does all the individual REST interactions one by one. You know, first search if the patient already exists. If it does, do an update. If it doesn't, do a create. If there are multiples, throw an error. So that's actually what we did. We had a small script. So that would enable us to process the transactions that we created, even on a server that doesn't have all these super features like conditional update, conditional delete, may not even have transaction processing capability. So we can just dump it all down to plain REST interactions. So coming to one of my favorite quotes from one of my favorite people, you can move complexity around, but you can't make it go away. So in terms of mapping V2 to FHIR, that means we have the option of moving the complexity from the client to the server depending on which solution we choose. If we create just message bundles, that's pretty easy for the server to do because we just have to do the field-by-field mapping. We don't have to care about the business logic or all the transaction and conditionals and all that stuff. We just put it in a message bundle, post it on the server, and the server has to figure out how to process it. So that's where the complexity for the server is the highest, because it has to do all the processing logic. With transaction, we're somewhere in the middle, because as a client, we have to do all this explaining to the server of how to handle it. The server, however, has to have these complex API features like conditional update, conditional delete, and all that kind of stuff. And the last option is to really dump it all down to plain, a multitude of plain REST interactions between client and server, which is probably the hardest to do on the client side, but the easiest for the server to handle. So, running out of time, but just to give you an idea of what else you could do, we have this one solved, ADT message to transaction bundle, to get the ADT messages there. But we may also want to communicate in the other direction, getting maybe measurements or whatever these mobile devices are doing or capturing, getting this stuff back to the version 2 engine as maybe an ORU message or something like that. The way you could do that, or the easiest way to handle that, is to just poll the FHIR server by using the history interaction and say, hey, was there something new in the last 2 minutes or since I last asked? Has anything happened? And the server will give you back all of the new observations, all the changed and all the deleted observations. So from there you can then, in just vice versa, you can create the ORU messages for the V2 system. However, the history bundle has a few downsides. You have to do polling, so there's always going to be a delay. There's no real-time data, and there's no, you cannot select. You just get everything that changes, all the observations. If you only care about a specific subset of observations, and if you care about real-time information, you may want to look at the subscription instead. So that's another way to solve this problem, which has a few advantages, but also a few disadvantages. Like right now, there's no reliability in the subscription. We don't have to find what we do if the client doesn't answer or misses a subscription ping. And we don't know how to trigger a subscription if your selection criteria is no longer matched. So there has been a Birds of a Feather session yesterday about how to improve subscription. So if you're interested in using that, you may want to join the Connectathon in New Orleans, where we are going to test a few improvements to the subscription resource to make it more workable for this kind of solution. So, I think we don't have any more time for questions, but maybe if there's one or two short questions, we can read a little bit into the coffee break. Otherwise, just meet me wherever I am today and just ask. Thank you.